am just going to give you a quick rundown on some of these functions I made before I pass them into the class. Basically, I was a little bit frustrated with our rectangular block and our rectangular prism setting because it went based on X and Y positive no matter what direction you were facing, and I wanted to make it so that it would face in the direction you were facing or appear in the direction you were facing instead of wherever. So if you're facing head on, then it will split the difference and make it right in front of you. If you're facing kind of towards a corner, it'll make it off to one side and things like that. Let me show it over here. So let's see. I want rectangle and I want size equals vector 4 by 4 by 4. It'll ignore that Y4 that's in the middle, and I want it to be vec, not vector. And then I want block type to equal block dot wool dot ID. I don't care about the data. Position. It should be reading my position, but it's caching that somehow, so I'm going to put that in even though it is the default. Same with direction. So when you run it individually, it's fine, but when you run it in the interpreter, for some reason that I haven't quite figured out, it doesn't update the my position and the my directory calls. So now I have a rectangle right there in front of me, but if I just turn and run it again, I'll have it there, and it's a little bit underneath me too. And it doesn't look like it's not 4 by 4 because it combined with the other one. So anyway, the idea is that now the rectangle will actually appear where you want it to, instead of you having to guess which X and Y and everything you're in. And the same with rectangular prisms, and even better with a rectangular prism with a hollow one, you can actually pass the vector 0, 0, 0 so that you end up inside of that prism. So let me run this real quick. I don't want it to be 10 by 10 by 10, 5 by 5 by 5 should be enough. Hit enter. Oh, I need to hit a block type in here. So syntax error. Positional argument follows keyword argument. It means that I said what the size was with an equal sign, and I did not say what the block wool was. I used a positional argument with that because it's the second one in line. And so I need to say what that is. There. And I'm going to need to do the same thing with this 5 and say data equals 5. There. And I didn't type wool correctly. There we go. And so now it's all dark because I'm inside of a giant wool block. If I just hit one thing down here, we can get some light here, and we can see that I spawned the whole rectangular prism outside of me, and I'm directly in the middle. And I did that with the 0, 0, 0 here. Now, this might not make a ton of sense yet, but I wanted to demonstrate what I made everything do, and now I will go back and explain how I did it. So over here, we're going to go through my functions bit by bit. So my position hasn't changed. That just returns my position instead of me having to call it each time with that big long bit. It's just for ease of use. Now, simplified direction has changed. Let me explain that. So, or direction has changed. This is new. So I am using the entity getDirection function that comes with Minecraft Pi to find out what direction I am facing. But if I do that in my interpreter down here, you'll see that that's a big ugly set of vectors. And I would like my cubes or my rectangular prisms and my rectangles to be nice and online, so I'm not having a weird diagonal line that's getting drawn. So I want to clean these up and just decide, am I facing left, right, up, or down? And the way I do that is I call this simplifyDir command. And what that does is it says, is this, so I call it for X, sending the X part. And over here, my X, as you can see, is this big, long float number. That means decimal number, 0.66. And what I decided was that if it was less than 0.5, I just wanted to round down to -1. And then if it was between, if it was less than -0.5. And if it was between -0.5 and +0.5, I just wanted to be 0, so I was facing straight ahead. And if it was anything larger than 0.5, I just wanted to round it up to 1. So this basically says that I am facing in one of 4 directions. I'm either facing straight ahead or straight back with no y value involved, or x value involved, or I'm facing left, or I'm facing right. And so that is how I decide whether the block is going to be, that's how I decide what direction the block is going to be in. I could have simplified it further and just said if it's negative, it's -1, and if it's positive, it's +1. But I wanted to allow the block to be centered in front of me. Okay, so next, that's how I get what direction I'm in. So if we look at our rectangle, by default, I call myDirection. Now remember, if I did 0, 0, 0, that just says that I'm right smack dab in the middle of what I want it, or it'll make the block surround me, okay? Also, one detail before I forget, I turned size into a vector, so I could just pass the vector around for all of these different directions and offsets I'm doing, rather than having to pass individual x, y, and z variables. So that just makes it a little bit neater for me. So instead of having diff x, diff y, and diff z, I have just a size vector of x, y, and z. Now, I can send an offset to my rectangular. This is where it's going to be as far as where I'm concerned, where it's going to start. But in general, I don't want to do that except for when I have an empty rectangle. I'll explain offset here more in a second. But my point here is that in general, for rectangle, I want to be calculating my offset with the computer, not manually, because that is based on my direction. So I just want to make sure, again, that I calculate that with a function, not send it over to myself. Now let's talk about what this offset does. Before, when I created a square or a prism or whatever it is, it created by starting where I was and then adding the X and the Z position. I don't want to just add the X and the Z position without thinking about what direction I want my square to be in. So if I'm facing in this direction and I do a square, I don't want it to apply behind me because I was facing in a negative direction and didn't realize it. So what the offset does is it determines where the square starts. So before, it always started right where I am. Now it'll start in such a way as to place the square in front of me in a way that makes sense. So if I come over here, I calculate the offset by using my direction. And if I say that I'm facing in the negative direction, so if I'm facing -1, because this is our simplified direction, I want the offset to be negative size. And that's the negative size in that direction. So it means I want my square, my rectangular prism to start away from me and build itself towards me, instead of starting at me and building itself behind me. So that's where that offset comes in. If I'm in the direction of 0, which means I'm not facing negative or positive in that direction, that I'm facing straight on in the Z direction, then what I want to do is have my offset be by half. So it'll start the square on one side of me, build it over, and finish it on the other side of me so that it's centered on me. And then if I'm facing in a positive direction, that was already a desirable behavior. That was already what we wanted. So my offset will be 0. It'll do exactly what it did before. And so in order to get that offset, I need to get it for the whole vector. I need to get it in the X, Y, and Z position. So I pass over the size of my vector and the direction I'm facing in to get offset vector. I set the offset to 0, 0, 0 so that I have something to change. Okay, I can't just start telling it that this is a vector without having explicitly told it first. And then I get my X offset, I get my Y offset, and I get my Z offset, and then I return what the offset is, and that's what this offset here is equal to. So now, after I've got my offset, all I do is when I change my X each time, it's my position plus I for each new block plus my offset. So that's how much I'm changing it by. I do the same thing for Z. It's my Z position plus whatever block I'm in the row or column, and how much my offset was by. The offset doesn't change each time because that just affects where we started. And then I set my block. So everything else about my rectangle is the same. I had to, for the empty rectangle, you don't want to calculate the offset twice. You only want to calculate it the first time. And so what I did for that is that's why we pass an offset off to the rectangle thing. So I calculate the offset for the empty rectangle. I calculate it for the outside, and I send it. I update my new positions. I calculate and I send off that same old offset. So that's the only reason we can pass offset as a variable, is so that my empty rectangle doesn't have it recalculate offset with a new shape and size, because we've moved around and that just doesn't work. And I did the exact same thing with the rectangular prism, except we're just calculating the offset in the Y direction as well, which we were already calculating it, but now we're actually making use of it. And the only reason we were calculating it before was because it's easier to write one function than it is to write two that do basically the same thing. And it didn't matter. Same for the hollow prism. I calculate the offset the first time in here, and I pass that one on to rectangular prism. And that's it. So basically, if you understood some of what was going on there, that's great. I don't expect you to replicate this on your own. I do want you to understand it well enough to be able to call these various functions. And the important part to take away from this is now these functions will go in front of you. The rectangular prism and the rectangles will form in front of you instead of in the positive X and Z direction, no matter what direction you're facing. We're going to use all of those things to create an aquarium, but we'll do that in another video. I just wanted to walk you through all of these and what they did. You can send your direction on its own in case you do actually want to have something form behind you. Like if you're walking along and as you walk you want it to do something, you can send that direction along. I guess it's not going to send it behind you though, it's going to send it always in the positive direction is the detail to account for there. Okay,